So first, an introduction. I'm not an academic. I'm not a machine learning or AI expert. I'm an engineer. And most of my time in the last 30 years has been spent making things go faster. So I think the first processor I used was about 4 megahertz, and it had a couple of K. And one of the first things that I did was write a compiler that generated executable code. So comparing against a Microsoft compiler, I think it was about 12K for printf hello world. And the compiler that I worked on produced the same output in about 243 bytes. This showed me that with clever coding and understanding your hardware, you can achieve wonderful things. So now I'm going to get into the problem statement, inference on low-end devices. So this week I've heard about the wonderful hardware that HPC gets to run on. The size of the systems, the number of processors, the amount of memory, the fact that you get peak utilization 4% of the time. I would love to have that problem. It's the opposite on a low-end device where you're aiming to get below 100% utilization in order that you can do the things that you need to do. I'm not going to talk about training at all. That is an end goal that hopefully we'll be able to get to do training as well on these more resource-constrained devices. But for right now, this talk focuses mainly on issues with inference. So you may wonder why. Why do we even care about inference on low-end devices when we have the cloud, and the cloud can do everything? And there are good questions. So in summary, I'll cover these in subsequent slides, but there are privacy issues, there are financial issues, there's do you always have access to a network? We don't have pervasive 5G yet, and there are latency concerns. The other thing is, okay, you want to run inference on a low-end device, but why? And the answer to that is that there are multiple use cases. So you may want to do voice processing on a phone, on a watch, on a TV. You may want to take advantage of networks that perform super resolution. So you've taken a picture, it's not particularly high quality, and you'd like to see it on your 8K or perhaps even 16K TV without it looking blocky. How do we achieve this? And super resolution is a way forward. Style transfer is another application for things like ambient art scenarios, where you have a picture that you've taken, and perhaps you want to see what that picture would look like if Van Gogh had painted it for you. So as an expansion on that, why on-device AI? Starting with privacy. So in the EU, we have GDPR. You may have noticed recently that when you go to a website, you're getting lots of pop-ups that are prompting you to sign your life away and telling you that what the company is going to do with the information that you're disclosing by using the website. Recently, I think there was a disclosure from Facebook that 100 million users' passwords had been leaked. And for some reason, they were stored in plain text in the database, which isn't really ideal. But all of these things reinforce in users' minds the need for privacy. They don't want all of their personal details, be that credit card, viewing interests, spread all over the internet for anybody to access. So server costs, we've spoken quite a lot this week about servers and the increase in capability and processing. This is a wonderful thing, but it does come with a cost. So the more devices that you have that are shooting information into the cloud, the bigger the servers need to be, the more servers that you need. Unfortunately, these things aren't all free. You do have to pay for them. Companies need to buy the servers. You then need to run them. The energy costs are monumental. There are energy costs, heating, temperature, cooling, all sorts of things that drive the cost at the server level just hugely. From the networking side, and again, assuming that you have pervasive access to a network, which you don't, and Brent was talking about this earlier, the internet is designed for downstream dissemination. It isn't designed for sending tons and tons of information back. As devices become more prevalent, so you have more of them, they want to do more, they're becoming smarter, smarter in the sense that they are generating more data that they want to shove up to the cloud. So then your network bandwidth becomes an issue, and then that feeds into latency. So if I want to instruct my TV to change the channel, so I talk into my remote control, the audio goes to the TV, it's packaged up into the internet packets, it's sent to a server somewhere, the server decides what I'm saying, it sends a response back, the local processing looks at the response, figures out what it needs to do. There may be quite a lag in between these two things. And if that processing was actually done on device, then hopefully you could reduce that lag quite a lot. All of these issues that I've mentioned all have potential solutions, or at least possible or partial solutions, by doing the work on the device itself. So from a privacy point of view, if your credit card details and your viewing history are kept solely on the device, it never needs to go anywhere, but you get the benefits of data personalization. So it may know that you like watching Real Housewives of Dallas and suggest Real Housewives of wherever else. You may not want the rest of the world to know. That's up to you. Server cost, the less data that we send up to the cloud, the less space that you have to buy, the less capacity you need to buy, saves you money. Again, if we're not sending data, we're not paying for it, we're not congesting the bandwidth that we are, and hopefully we reduce that latency. So now I've convinced you that on-device AI is a good thing. You may be wondering why you want it on your TV, and it's a reasonable question. So at the bottom there, we have an image of a man. It's not me, although we are both bald, looking out over a nice landscape, and maybe he's musing, I wonder what this would look like in a different style, perhaps Van Gogh, perhaps something else, and then the image on the right shows his image, the image that's been taken in that style. I'm sure you can appreciate that your friends and family would get endless joy out of things like this, and viewing your pet in all sorts of different ways would be obviously interesting for a cat-based internet such as we have. So that addresses style transfer voice processing. Again, it's cutting down on the latency. We don't want to be pushing the data up. We may have privacy concerns. We may be worried that our devices are listening to us, and we don't want that. We want to know that everything is confined to the device. Content understanding. Your TV may notice that you like watching films with Kevin Costner in, or Zac Efron, or whoever your favorite star is. Once it realizes that you like these particular actors, or you like particular genres of movies, it may then want to suggest to you that, hey, did you know there's a new film coming out? Maybe it knows that you like Game of Thrones. It could tell you that, hey, Game of Thrones season 8 has started. You may be interested in that sort of thing. Super resolution, where you have images being captured on all of your portable devices and want to view them in all their glory on a big screen, helps you to get that high quality upscaling that we're all looking for. And your great idea here too. So you don't need to think about AI as something that is done primarily in the cloud, and you need 20 NVIDIA GTI 1780s in order to make the best of it. It can be done on a TV, and by making your AI work on a TV, you're potentially impacting a larger number of people. So I've convinced you, you've all got your skates on, you're ready to go. However, there are some issues, and I'll move on to those now. So less is more, yes. So I have a watch here. It's very low power compared to a desktop computer, but fridges, your washing machine, your microwave, your TV, they have less CPU cores, which are less powerful. They have less memory generally, they have less storage space, they have less GPU, and now we get into the less is more pun. This brings more headaches. So we have less memory, but the models are large, and we need to get the large models into a small space. We don't have a lot of storage available, so we can't cache a lot of data, which would help in the computational lag and speed things up. The bandwidth of the memory may be an issue. We can't shift megabytes of data around hugely quickly. And model designers on their lovely NVIDIA systems are not really thinking about my watch when they're designing their models, and that's a problem. However, it's not all bad, and this largely pertains to a TV. So in these architectures, typically the CPU and the GPU have shared memory. So you don't have to load it once, copy, move it around, and do all this other stuff. It's just there anyway. We have restricted execution modes. There's generally less going on. When you're just watching TV, there aren't any menus or anything else going on. The GPU inside is doing nothing. So we could be making use of this. TVs also don't have power constraints. They're plugged into the wall. We're not worried about battery. Thermal isn't an issue. So all the time that your GPU sat there doing nothing, it could be doing something. It could be going through all of your pictures in the background and converting them to super resolution images, for example, or waiting for you to talk to it. But we need to remain responsive, and throughput and latency are both important. So, call to action. I heard this quote at CGO 19 and it scared me quite a bit. Inference on device is not a solved problem, so please don't believe that it is. We need to address this in a variety of different ways. We need better tools to help people design better models. We need community engagement, and low-end devices need to be considered early. So please design models thinking that you're going to run on a tiny little watch. And then when you put it on a big system, it'll run even faster and life will be good. So echoing Lord Kitchener here, your country needs you to produce smaller models and faster models for low-end devices. Thank you.